Scientific notation. Did you know the sun is about 150 million kilometers from Earth? That number is huge, and writing numbers like this all the time is messy. Scientific notation makes big and tiny numbers easier to read. Now, what is scientific notation? Scientific notation is just a shorter way to write very big numbers or very small numbers. Now, a very important rule is that the first number over here must always be between 1 and 10. So it must always be between 1 and 10. Here are some examples. This is 3.5, which is between 1 and 10, that is correct. 7.2, which is also between 1 and 10, that is also correct. Now 35 is not between 1 and 10, so therefore this is not a correct way to use scientific notation. So always remember this important rule before we move on further. Big numbers. Now, in order to get a big number into scientific notation, you have to move the decimal until the number is between 1 and 10. For example, let's put an imaginary decimal over here. Okay, that is 0. Now let's move it one over here. That is 1. Let's move it again over here. That is 2. Let's move it again over here. That is 3. There's 3 times moved, but it's still not between 1 and 10 because the number over here is 45. So now we must move it one more time over here. Then it's 4.5, and 4.5 is more than 1 and less than 10. Therefore 4.5 is our correct answer. And we move the decimal how much times? 1, 2, 3, 4. So we move the decimal 4 times. So therefore we write here 4.5 times 10 is to the power of 4, and this 4 comes from moving the decimal 4 times. So we start here, this is 0, move here, this is 1, move here, this is 2, move here, this is 3, then we move here again, this is 4. Okay, remember we move the decimal 4 times, this is why the number over here is 4. Decimal 4 times, or whatever amount of times until the number is between 1 and 10. And another rule to note is when we move the decimal to the left, like we did here, these are all left side. We're moving the decimal to the left side. The exponent is positive exponent. Like this over here is positive 4. Small numbers. Now if you see this number over here, there is already a decimal point over here. So if we want this number between 1 and 10, we must move this decimal point until it gets over here. But we must count our moves. So now let's move it once over. That will be 0.032. That is still not between 1 and 10. Let's move it again over. That's 0.32. That's still not between 1 and 10. Let's move it one more time over. That's 3.2, and 3.2 is between 1 and 10, so it does fit our restrictions. And if we count how many times we move the decimal point, it will be 1, 2, 3. 1, 2, 3 times. But we are moving the decimal point to the right, and that would mean, let's say, negative exponent. Remember this important rule: when we move the decimal to the right, it will be a negative exponent. So if you see over here, that's negative 3, and the 3 is from over here because of how many times we move the decimal point. So it'll be 3.2 times 10 to the power of negative 3. Okay, hope you guys understand. That's very easy to learn. Converting scientific notation back to normal. Let's look at this. 6.1 times 10 to the power of 3. Now, in order to get this into 6,100 over here, 6.1, we must move the decimal place 3 times to the right because of the number 3 over here. Okay, now we take the decimal point and we move it 1 point to the right. That will become 61. And let's add an imaginary 0 over here, so it's 61.0. But we need to move the decimal point 2 more times to the right. So let's move it over here. That will become 610. And let's add another imaginary 0, but we still need to move the decimal point 1 more time to the right. So it's the third time. And then this number will become 6,100. As you can see, we moved it 1, 2, 3 times to the right for the number 3 over here. The number 3 over here is why we moved it 3 times to the right. And that results in the number being 6,100. Now let's do another one, but this time with a negative exponent. So it's 8.4 times 10 to the power of negative 2. And we want that to be equal to 0.084. Number 8.4. So what you want to do is you want to move the exponent to the left because it's a negative. Move the decimal point to the left, but let's not forget the imaginary 0 over here, and the decimal point moves over here. That's once. Erase this over here. So now the number is 0.84. 0.84. Now let's move the decimal point 1 more time to the left. Over here, let's not forget the imaginary 0, and it's the second time I'm moving it to the left. Let me erase this. So now the number becomes 0.084. 0.084, which is this number over here. And remember, the reason why I'm moving it twice to the left is because of the negative 2 over here. Okay, you see the negative 2 over here is why I'm moving it twice to the left. And if this was a positive, I would move it twice to the right. Twice to the right if it was a positive. Okay, I just want to take you through some basic calculations. When multiplying scientific notation, you multiply the numbers, like the basic integers, and you add the exponents. You multiply the numbers and you add the exponents. For example, what's 2 times 3? That is equal to 6 over here. 6. And what is 10 to the power of 3 times by 10 to the power of 2? So you add the exponents over here, and that will be equal to 10 is to the power of 5. Here's some examples of real life use. For example, scientists use scientific notation to calculate tiny bacteria sizes, as you can see over here, and the speed of light. So the speed of light is 6.71 times 10 to the power of 8 miles per hour. So as you can see, these are negatives exponents, so the decimal point will be moved to the left each time over here. Like centi, milli, micro, nano. And the speed of light is a positive because of how fast it goes. So 6.71 times 10 to the power of 8, that's positive. Quick quiz. Write 32,000 in scientific notation. So you remember, in scientific notation, you want to get the first number in between 1 and 10. In between 1 and 10. So if you use your brain, you can tell very quickly that we want 3.2. So just by thinking about it just for a second, we want 3.2, because 3.2 is the only number here that we can take that will allow us to get this in between 1 and 10 in scientific notation. Okay, let's put this in scientific notation, times it by 10 to the power of what? Now we must get this number over here. What is this number over here? What's the exponent? Now let's write out the number 32,000. So let's put a decimal point over here that will make the number 3,200. Let's move it again over here. That will make the number 320. Let's put another one over here, 32. Let's put another one over here. That will make the number 3.2. But now let's count the number of decimal points we needed for it to become 3.2. So that would be 1, 2, 3, 4. 4. So that would mean the number over here will be 4, because we move the decimal 4 times to the left, and it will be positive, because remember, when we move left, it will be a positive power. Remember this, move left, positive power. Just remember this concept, and everything will be much easier when it comes to scientific notation. Move left equals positive number, move right equals negative number. Now, what is 5.6 times 10 to the power of 2 as a normal number? So what you want to do is you take 5.6, the number over here is 2. So you want to move the decimal point twice to the right. And the reason we're moving it to the right is because we're converting it from scientific notation back to a normal number. So this does not apply. In fact, it's the opposite. So 5.6, move the decimal point once to the right. Okay, that's once. Let's move it again to the right. That's twice. Now let me erase this. And that would result in the number being 560.0. Okay, I erased that, but just remember it's there. It's imaginary, but it's still there. And that is how we convert a number from scientific notation back to a normal number. Also, and remember, these rules are only and only when you convert a normal number into scientific notation, like over here. They are the other way around when you want to convert a number from scientific notation into a normal number. So when this was positive over here, the positive 2 over here, we moved the decimal point to the right. But as you can see, it says negative here, because this is only for converting a normal number into scientific notation. But when you convert a number from scientific notation into a normal number, these are the other way around. These over here are the other way around. And I want to finish off with the sentences. Scientific notation is just smart decimal movement. There's nothing too complicated about it. Okay, that's all for today's video. Make sure to like and subscribe, and see you in the next one.